Welcome to solverfy.
Now here the question is sketch a d-orbital energy diagram for the following. A is a linear complex ion with ligands on the x-axis and B is a linear complex ion with ligands on the y-axis. So these diagrams we have to make d-orbital energy diagram for a linear complex with ligands on the x-axis. Means this complex is metal at the center and linear complex, that means 180 angle, and ligands are present here. This is the linear complex and this is present in x-axis. So this is given and the question is we have to sketch a d-orbital energy diagram for the following. So d-orbital, in presence of ligand we know that a splitting is taking place, and if 5 d orbitals are like this, 5, then it is x-axis, that means the highest should be, suppose here, highest is here, and that should be which d orbital? It is dx square minus y square. And after that the energy of this will be higher. These two, one is dxy and second one is dxz, and the lowest energy will be two orbitals. One should be dyz and next should be dz square. So this is the splitting which is taking place. So we can say that lowest energy level should be this one, and after that this is the energy level, and highest energy level splitting is this one. So actually splitting of the d orbitals are taking place due to interaction of the metal and ligand. If the repulsion is more, energy of that orbital should be more, and repulsion is maximum when ligands or ligand is coming along the x-axis here, then the d orbital along this axis only it is coming, so it should have the highest repulsion, and we can say it is having highest energy. So it should have maximum energy, and then xy, dxy and dxz same energy, and the lowest is where x-axis is not present, that is dyz and dz square. That should have minimum energy because here it is quite far from the x-axis and repulsion is minimum. That is why the energy is minimum. Now come to B. This is A. Now come to B. In the B, it is said that the d orbital diagram where the linear complex with ligands on the y-axis. So it should be M at the center, that is the metal atom, and one side it should be one ligand, and second side is again ligand, but this is linear complex, so linear structure must be there, and angle will be 180 degree, and this axis where the ligands are present should be y-axis. This is y-axis. When y-axis is present, then what will be the type of splitting, and in which orbital the repulsion is maximum and energy is maximum, that we have to decide. So if these are the 5 orbitals here also, 5, then the highest energy should be where the x orbital, along the y orbital, this is coming, ligands are coming, repulsion is maximum in case of this orbital, which is dx square minus y square. This is along the y-axis, so that is why repulsion is maximum in this case and energy will be highest. After that, it should be 2 orbitals where y is present, because it is closer to y-axis, so repulsion will be slightly lesser here, and that is why the energy is also less. So here it is dxy and dyz. Then again 2 orbital where these orbitals are quite far from y-axis, and that is why the energy is minimum here, and these orbitals should be dxz. You can recognize it by just looking at the name. No y present, that means they are far from y, and that is why the repulsion is minimum here. So the lowest energy levels d orbitals are dxz and dz square. And when it's a question of splitting of the orbital, you can say the splitting is taking place like this only. Highest is this one, and after that it should be this one, and the lowest is this one. So this is the d orbital energy diagram for the following linear complexes when they are present, ligands are present in x-axis and in y-axis.